Hey everyone, hope you're doing well today. We got another request on a video I uploaded a couple of days ago where people can kind of make their suggestions and say the videos they want. You can find that on my channel. I might actually leave it down below if you want to participate in that, and you can leave a request. It is just for GCSE level though, so I kind of explain it a bit more in the video, but check it out if you think you have a question that's going to be at GCSE level or below. So for the circle theorem proofs, that was the request. I will probably make a few videos over a period of time and just add them to a playlist on my channel. So I don't know how long it will take, but I'll do that over time and slowly add them. And yeah, hopefully I should get all of them in a pretty short time. So let's get into the first proof, and that is angle in a semicircle proof. We need to prove that the angle at the top of this triangle is 90 degrees, although we're not meant to know that yet. We're just trying to find the size of that angle. We've obviously got a circle here. The red dot is the center, and then the bottom of the triangle is the diameter of the circle, and then we've got these two other lines meeting. First thing you're going to want to do is draw this line here. You draw it from the center of the circle to the top part of the triangle. Next, you want to label every length, which is the radius, so that's what R stands for, and the radius is the length from the center of a circle to the edge of the circle. And because all these lines are going from the center of the circle to the edge of the circle, we can label them all R. We know they're all going to be the same length, and they are classified as the radius. So you may or you may not notice there's two separate triangles, and that's why I've popped in this XXYY, and I will explain how I've jumped to this step. So there's obviously two triangles now, and because they both have traits of an isosceles triangle, we can work out that, well, two of the angles are going to be the same. So for example, the one on the left, it has two sides that are length R. So because it has two sides of the same length, it's classed as an isosceles triangle. So these two angles here are going to be the same. The X ones, we're going to have X and X. And the same applies for the triangle on the right. It has two side lengths which are the exact same length, so we can label these as Y and Y. And that is literally just taking the fact that they are isosceles triangles. Obviously, they're not exactly the same triangle because they have different angles and they have a third side length which is different. So hopefully that will make sense so far. Obviously leave some comments if you have any questions about this. Next step, we want to remove all the R labels and remove that extra line I put in at the beginning. And by doing so, that's going to leave us with one triangle with X, Y and X plus Y as angles. And you can always skip between this image and the previous one. You can kind of see, oh, okay, so we had the X and Y at the top. Now that's just X and Y because we removed that line. Then we have the X on the bottom and Y on the bottom. So hopefully you can see how we've jumped to this point. Now from here, we're going to move this over a little bit to have some room to write. So we're going to finish off the proof with the fact that all angles in a triangle add up to 180 degrees. So we've got X plus Y plus Y is equal to 180 degrees. Add up all the X and Y's, so 2X plus 2Y is equal to 180 degrees. Divide both sides by 2. It's going to give us X plus Y is equal to 90 degrees. So we know that X plus Y added together is always going to be 90 degrees. And 90 degrees is a right angle, so that's always going to be a right angle. So hopefully that makes sense. If you do have, any comments or questions, you can drop them down below. But thanks again for the request. I hope the video helped. And yeah, if anything was confusing, drop it below. Thanks so much for watching and best of luck with your maths. Hey everyone, welcome to my circle theorem proof video, and this is angles in the same segment proof. This will be part of a playlist which covers the circle theorem proofs for GCSE, so let's get into this one. So for this proof, we're basically proving that X and Y are the same size angle, and to do this we're going to be using a previous theorem that I haven't proved yet on my channel, but we're going to be using this theorem to prove another theorem, which is going to be this theorem. First thing I want you to do is visualize the X and the Z. So for example, we just have this image, we have the X and the Z. Then next we're just going to visualize and look at the Y and the Z. Now this is going to help when I apply the theorem if you just visualize it like this for a second. Now because of the previous theorem, we know that Z is equal to 2X and Z is equal to 2Y. Now why do we know that? That's because we're using a previous theorem that the angle in the center is twice that of the circumference. This is one of the circle theorems and you will have to prove it, and I will do a video on that. So we're using the previous theorem to help us prove this theorem, if that makes sense. So it's kind of like, I don't know, Inception or something. Anyway, so we've got Z is equal to 2X and Z is equal to 2Y because we know the angle in the middle is twice the, or the angle at the center, sorry, is twice that at the circumference. So you'd say Z is equal to 2X or Z is equal to 2Y. Cool. Hopefully that all makes sense. And then I've just written this is by using the theorem that angles at the center are double those at the circumference. So now we've used this theorem, we can just put 2x is equal to 2y because z is equal to z obviously. Divide both sides by 2, so we've got x is equal to y. So that's pretty much it. We've proved that x is equal to y, they're the same angle size, and yeah, I think this is probably one of the easier circle theorem proofs, so quite straightforward this one. And I will make sure I do a video to prove the theorem that we used to make this proof. Anyway, very wordy. Cool. Hopefully that makes sense. Any comments or questions, drop them down below. I know I said it was easy, but if you don't get it, just let me know and I'll try my best to explain it a bit better. Thanks so much for watching, and I'll leave whatever relevant stuff below. And yeah, best of luck with your maths. Thanks for watching the video and appreciate all the, support from you guys. Thanks for watching. Hey everyone, so today I'm doing another circle theorem proof video, and this one is going to be on opposite angles in a cyclic quadrilateral. So as you can see, we have a circle with a quadrilateral within it, which is a four-sided shape. We've also got a red dot in the middle of the circle, and the corners of the quadrilateral touch the circumference or edge of the circle. We need to prove that the opposite angles within the quadrilateral add up to 180 degrees. So we start doing that by putting these two lines in. So these lines go from the center of the circle to the corners of the quadrilateral. You want to do two lines on the opposite corners. Doesn't really matter which one. I've just gone for ones that create more of an obvious bend or obvious angle, but really doesn't matter. So you put these two lines in, and then you want to start labeling the other angles or the other corners. So for example, you can see I put A on the left hand side corner of the quadrilateral, and then in the middle I put 2a. Now I've done this because I've actually used another theorem which is proved separately in another video. I haven't made the video yet, but I will get around to doing that, and it's that the angle at the circumference or the edge of the circle, when you have that angle in the center of the circle, it's going to be twice the size. So we have A, and when it's at the center, it's 2a. So that's another theorem, and that's for another video, but you can take that for granted now, and by the time I end up making a proof on it, you can watch that too. So we've used that fact to label A and 2a. We're going to do the same for the opposite sides. So we're going to label B, which is the opposite to A, and then 2b is going to be opposite to A. You can kind of visually see what I've done here. So we've got B and 2b, same principle is applied. That's how I was able to label that as well. Now from here is where we can start writing the proof, I guess. And that's because 2a and 2b in the middle, they're going to add up to 360 degrees because it's just a big circle. And if you go around in a big circle, it's 360 degrees. So we've got 2a plus 2b is 360 degrees. Great. Next thing we want to do is divide both sides by 2. So we're going to get a plus b is equal to 180 degrees. And there we go. We've basically just proven the theorem. It really is that simple. Hopefully it all made sense. If anything wasn't clear, please leave a comment down below and I'll do my best to get back to you there. Thanks so much for watching the video and best of luck with all your maths. Hey everyone, so today we're doing another circle theorem proof, and today we're doing the angles at the circumference and center proof. So we're basically proving that angles at the center are twice that at the circumference. So for example, we can see 2 and 2b, we're going to prove this theorem. First thing we want to do is get rid of our b and 2b and just start from scratch. We're going to pop this line in here, and then we're going to mark them all as r. So r stands for the radius, and the radius is just the distance from the center of the circle to the edge of the circle, otherwise known as the circumference. Now from here, I've labeled two isosceles triangles. Now, they're isosceles triangles because they have two side lengths that are the same. For example, the one on the top has r, and then it has an unknown length. And then the one on the right has r, and it has an unknown length. So I've been able to label the angles WW and then X, and then YY and Z. And this might be one of the harder proofs, so if you do have any comments or questions or anything isn't clear, drop a comment down below and I will fill in any blanks there, or fill in any spaces there. So carrying on with the proof, we're going to put x is equal to 180 degrees minus 2w, and then z equal to 180 degrees minus 2y, and that's because all the angles in a triangle add up to 180 degrees. So for example, x plus w, or x plus 2w is going to be equal to 180 degrees. We've rearranged that to get x is equal to 180 degrees minus 2w, and we've done the same for z is equal to 180 degrees degrees minus 2y. Next, I want to put in this new angle v, and that's going to give us x plus z plus v is equal to 360 degrees, because there's 360 degrees in a full spin or a full circle. And then using this bit of information, we can sub in our x and z values. So we've got 180 degrees minus 2w plus 180 degrees minus 2y plus v is equal to 360 degrees. That's just because we've subbed in the values for x and z that we've listed at the top. Now adding up the 180 degrees, so we've got 360 degrees minus 2w minus 2y plus v is equal to 360 degrees. And now I've just moved this bottom line to the top to clear some more space. The 360 degrees cancel out, or you can say we've subtracted 360 degrees from both sides. So I've just rearranged this equation. I've added 2w plus 2y to the right hand side. So we've got v is equal to 2w plus 2y, and we can take a factor of 2 out, so v is equal to 2 times w plus y. Next thing I'm going to do is remove all the unnecessary lines, but I haven't actually changed the angles. So for example, we've got w plus y in there still, and we've got v in there still. So hopefully you can see from here how the theorem works, but what we can actually do is sub in 2 times w plus y for v, because v is equal to 2 times w plus y. So whatever w plus y is, it doesn't really matter, you can pick numbers, but let's say w plus y is 30, let's say they're both 15 or whatever, then the angle in the middle is going to be 2 times that, so it's going to be 60. So we can see how we've proven the fact that angles at the center of this circle are going to be twice that of those at the circumference. So hopefully that makes sense, hopefully it was clear. I feel like this pretty much proves the theorem, so yeah, again, if you have any questions, drop them down below. I hope this helped you guys, and best of luck with all your maths. Thanks for watching. Hey everyone, so this is another circle theorem proof, and today we're doing an alternative segment proof. So we basically need to prove that A and B are the same size. So the first thing you're going to want to do is put in these two radius lengths, and by doing that we make an isosceles triangle. So I've split the isosceles triangle in half, and I've created two more triangles. I've labelled them with identical values, so x, y, and then a right angle. Now from here it's good to point out that the radius makes a 90-degree angle with the tangent, so that's why I'm going to put this square in here. And as it's 90 degrees, we know a plus x is going to be 90 degrees, so that's our starting point for our proof. Next thing we know is that everything in one of our little triangles we've made adds up to 180 degrees. So x plus y plus 90 degrees is equal to 180 degrees, and if we simplify that second expression we get x plus y is 90 degrees. So from here we can see that these are very similar, so a plus x is equal to 90 degrees and x plus y is equal to 90 degrees. So inferring from that we know that a is equal to y. Then we need to use the center circumference theorem, which is a theorem I previously proved on my channel, and that is that the angle at the center is twice that the angle at the circumference. So 2 times b, because b is the angle at the circumference, is going to be equal to 2y. From there we can divide both sides by 2, so b is just going to be equal to y, and as a is equal to y and b is equal to y, we know a is equal to b. So that's the theorem. I realize it was quite straightforward and to the point, so if you do have any comments or questions that you wish me to expand on, please just let me know down below and I'll do my best to get back to you there. Best of luck with all your maths and thanks for watching. Okay, so this is the last theorem I'm going to be proving for the circle theorems playlist, and this one is a lot more wordy than the other ones, so kind of bear with, it's a bit different. I feel like it's not as straightforward as doing a maths one, but yeah, let's stick to it and see how it goes. So this is the circle theorem proof for radius and tangent meeting at 90-degree proof. So basically we're proving that this line AD, when it meets the circle, the radius is going to be at 90 degrees. That's the OB line. Well, we can't assume that yet, but that's pretty much the proof we're going to prove. So firstly, let's assume that OB is not perpendicular to AD. So we all pretty much know that it's going to be line OB that is at a right angle to AD, but let's assume it isn't for the purpose of this proof. And let's assume that OC is the perpendicular line. I mean, obviously it isn't from the visual, but let's assume it is. So if OCB is equal to 90 degrees, which is a right angle, then OBC would be acute. So if you look at that triangle, if you have a 90-degree angle in the triangle, all the angles in the triangle have to add up to 180 degrees. And if one is 90 degrees, the other two are going to add up to 90 degrees also, but it's one of them's going to have to be at least 1 degree, or at least a fraction of a degree. So there's not going to be another one that's bigger. So the other one is going to be smaller than 90 degrees. And in a triangle, the biggest side is opposite the biggest angle. So if OCB is the biggest angle, the biggest side will be OB. So OB is bigger than OC. which we can obviously see is wrong, but let's keep going with the theorem. However, OB is equal to OE because it's the radius. So OB and OE are both from the center to the circumference, so they're classed as the radius. Therefore, OE is greater than OC, but we can see this is incorrect because OE is the radius and OC goes beyond the radius. So this means that it is actually OB which is perpendicular to AD and not OC. And you basically go through this process of elimination to prove that the other points don't work. So through the process of elimination, the 90-degree angle is going to be OBC, or the perpendicular line is going to be OB. Now I realize this is quite a wordy one. It's not really my forte. I'm kind of better at just straight math. So if you do have any questions, I'll try to answer them, but no promises. But I'll do my best. As I said, I'm better with the mathsy parts, not so much the wordy parts. Anyway, I hope this helped. Best of luck with your maths, and thanks for watching the channel.